All right, guys, here's the explanation to all the answers from the worksheet on 5.1. Okay. All right, so for these first ones here, we're trying to evaluate these without a calculator. Okay, so we are looking to see 3 to what power gives you 1 over 81. That's what we're trying to do. Well, if it was just 81, all right, 3 to the 4th is 81. But since it's 1 over, that means what about our exponent? It means it's negative, right? So it's negative 4, all right? Because 3 to the negative 4th is 1 over 81, because you make an exponent positive by just moving it to the bottom, all right? Here, the natural log of the 5th root of e, all right? Now remember, the base with the natural log is e. So e to what power gives me the 5th root of e? Well, 5th root of e is just e to the 1/5. So 1/5 is my answer. All right. Now, whenever you have a log up in the exponent, whatever this number is here, which is e, if it's the same as its base that's up here in this log, which it is because the base of natural log is e, the answer is just whatever comes after. You can just simplify all of this to the square root of 3x minus 1. All right, d, natural log of e, is always 1. All right, so for e, let's look at just this part here. This is just like part c. All right, so we have a log up in the exponent. The base of the log is e, which is also the base here, which means this right here is just x squared. All of this is x squared, but there already was an x squared. What's x squared times x squared? X to the 4th. All right. With f, all right, log of, what is that, 100 cubed, all right? If there's no base written for a log, it's base 10. So 10 to what power is 100 cubed, all right? So a couple things you could do here. You can actually do what 100 cubed is. If you know 100 is really 10 squared, right? So it's 10 squared cubed, which is the same thing as 10 to the 6th. So the answer is 6, all right? 100 cubed is 1 and 6 zeros. So then you can figure out that 10 to the 6th would be, the 6 is what you have to be there. All right, for part G. All right, so this one can be a little bit tricky. What you have to realize is this plus 3 here, this is really natural log e to natural log of x squared plus e cubed, right? Sorry, times, all right? Because when you are multiplying and you have the same base, you add the exponent. So natural log of x squared plus 3, that's where that comes from, all right? So this first part of it is just like you did in c and e. So you have the same base, so that's going to be x squared, and then you have e cubed. So the answer is just x squared times e cubed. You can't do anything else with that. So there's your answer. All right. And the last one here for h. All right. This 3 can be moved. It's out front, which means this is really e to natural log of x cubed. We have the same base, so this is all just gone. It's just whatever's there, which is x cubed. All right. All right, so now with number 2, all right, we're using the laws of logs to rewrite is a sum, difference, or constant. All right, so we're just expanding these. All right, we're just expanding. Remember the rules for expanding: if you have a fraction, everything on top is positive, everything at the bottom is negative. Any exponents go to the front. All right, so for this one, there's no fraction, just be multiplication. There's 3 different terms here. So it's natural log of x plus the natural log of y. There's no exponents, so nothing has to go up front, plus the natural log of z. All right, natural log of x plus natural log of y plus natural log of z. All right, part B. All right, part B. So this is all of this fraction here is being raised to the 3rd. Okay, so we have x squared minus 1, we have x cubed. So we have 2 natural logs we're going to have to do. All right, we have a natural log with x squared minus 1, and it's going to be minus a natural log with x. Oops. All right, now this is being cubed. So that goes out the front, but it's also being cubed there, which means another 3 is going to go out front, which you get 9. This one is just to the first, so this is going to have a 3. All right, so both of these terms are being cubed. So the top's being cubed, that's why the 3 goes out front. The bottom is being cubed, but it's already being cubed at the beginning, so 3 times 3 is 9. So that's where we get the 9 from out front. All right, this one. All right, we have 1, 2, 3 things. So that's 3 natural logs. Exponents got in front. So it's going to be 5 natural log of x plus 4 natural log of 4x plus 3 minus, it's the fifth root, which is 1/5 natural log of 3x plus 2. All right, now, since this is all for D, all under a fourth root, that means we're going to multiply all of these by 1/4. So 3 times 4th, this is really 3/4, right? 2 times a 4th is really 1/2, right? So now we've already taken account that. These are just going to come out in front. So it's going to be 3/4 natural log of 3x minus 5. All right, and that's because we would have put the 3 in front. There's also a fourth root, which is a fourth. A fourth times 3 is 3/4. Minus, why is it minus? Because it's on the bottom. 1/2 because it was squared, but then we have a fourth, so 2 times a fourth is a half of, what is that, natural log of 8x minus 7. All right, so there is your expanding. All right. All right, this will be our condensing. Okay, so now we're just going to make one. It's going to just be one natural log. Okay, anything that is positive stays on top. Negatives in the bottom. Anything out in front is an exponent. There is nothing out in front here, so this is just x minus 2 over x plus 2. All right, here. All right, we have a natural log. All right. We have that 2, all right? This cube root, this 1/3 of everything on the outside means I'm just going to put everything under the cube root. And what do we have on top? We have x plus 3 squared. I have another x. And then on the bottom, I have an x squared minus 1. All right, the x can go out in front, can be behind. It doesn't make a difference. All right. For part C, we'll make one big natural log again. As soon as I see that negative, I know I'm going to have some sort of fraction. So 3, that's really x cubed. The 1/2 is really a square root. That's what, 3x plus 2. The minus, so that's x plus 4 squared. And then 1/3, which means that is the cubed root of 3x plus 5. All right. And you can put all in parentheses if you want. So that's x cubed, square root of 3x plus 2 over x plus 4 squared times the cube root of 3x plus 5. All right. Last one here with expanding. Once again, just going to make this into one log. All right. We do have a negative here, which means we have a fraction, which means it's going to be the cube root of 4x plus 5, because we have a 1/3, times 2/3. All right. Well, of x, so that's really the x to the 2/3 is the cube root of x squared. So I rewrite that. And the 1/5 is the fifth root of 5x minus 3. All right. Next section, number 4. All right. Now we are just sketching these. All right. We're just sketching. Rough sketch, you only need to use 1 point. Remember, the basic shape that we are using is we have for natural log, y equals natural log of x. Vertical asymptote, we have a point at 1, 0, and it looks like that. All right. So the negative out in front is a vertical flip. So nothing changes because the y coordinate is supposed to change. We're still at 1, 0, but instead of going that, it gets a vertical flip, so it looks like that. All right. The domain of that is going to be from 0 to infinity. All right. When you have a number inside the parentheses, this shifts it left or right. You set this equal to 0. So this is going to be -2. So it's just shifts it to the left 2. So we normally are at 1, 0. We're shift it to the left 2. We are going to be at negative 1, 0. And our asymptote is going to be at 2. And it looks just like that. And we are going to have from negative 2 to infinity is our domain. All right. So we're looking at the horizontal asymptote. If it's to the right of it, it goes to infinity. If it's on the left, it'd be negative infinity to whatever the horizontal asymptote is. This negative 1 moves my point down. My vertical asymptote stays where it is. That only moves like it did in B, where you shift it left or right. So normally at 1, 0, just move it down 1. So that is at 1, negative 1. Looks like that. So this is 0 to infinity. All right, set this equal. This is going to move it to the right 3, but this negative means we have a horizontal flip. So what's going to happen is we need to have our vertical asymptote, keep saying horizontal, our vertical asymptote at 3. All right, we normally at 1, 0. All right, it would get flipped to negative 1, 0, and to the right 3, it moves right here. All right, that's at positive 2, 0, and our domain, since on the left side is negative infinity to whatever the vertical asymptote is. Sorry if I said horizontal for it. I don't know. I think I might have said that. It's a vertical, obviously. All right, it's a vertical asymptote to 3. All right, last one. We got a negative here. That's a vertical flip. We have a negative in front of the X. That's a horizontal flip. And we have the plus 1, which moves it up 1. So since it's not shifting left or right, my asymptote is still at 0. So my normal point is at 1, 0. If I flip it horizontally, it goes over here because I flip over the y-axis. But then I flip it vertically, it does nothing. And then I just move it up 1. So at negative 1, 1 is the graph. And that looks like that. All right. And then our domain is negative infinity to, what is that? 0. All right. All right. You did not have to do 5. All right. So for 6, all right, for 6, we are doing, all right, for 6, we are doing some derivatives. All right. We are doing some derivatives. All right. So remember, the derivative of a natural log, and you can use your formula sheet, is du over u, which just basically means you take the derivative of the inside over the inside. So the derivative of 3x plus 5 is 3 over the inside, which is 3x plus 5. So you get 3 over 3x plus 5. All right. For this one, the derivative of x to the 4th is 4x cubed over x to the 4th, which then simplifies to 4 over x. All right, 4 over x. All right. The natural log of x, all of that raised to the 4th. All right. So with this one, you got to be a little careful. All right. This is like a chain rule. You got to bring the 4 out front, keep the inside the same. The 4 then becomes a 3, and then you take the derivative of the inside, which is just 1. The derivative of natural log of x is 1 over x. All right. So you can just leave it like that. You can put all of that over x. Put this part over here over x because that's what the same thing to combine it into 1. But leave it like that is also just fine. All right. Now for D, we have x squared. We have 2 terms here. This is the product rule, right? So this is the first times the derivative of the second plus the second times the derivative of the first. So it's x squared times the derivative sine 4x, which is 4 cosine 4x, because it's the derivative of the outside, which is sine, keep the inside the same, then times the derivative of the inside, plus sine 4x times 2x. All right. And you can just clean that up by moving that out in front, writing as 1, but you're all good from there. All right. This is all 1. This is not a product rule. All right. All of this is your inside. So the derivative of secant 4x is secant tangent, but you keep the inside the same. So it's secant 4x tangent 4x times the derivative of the inside, which is 4. So I'll put the 4 out front, all over secant 4x. All right. And then the secant 4x's cancel. So your final answer is 4 tangent 4x. All right. 4 tangent 4x. All right, with f, all right, this is the natural log of the cube root of 5x minus 4, right? You could rewrite this as 1/3 natural log of 5x minus 4, right? Because this is to the 1/3, then you can move it out front. So it's 1/3 times the derivative of 5x minus 4 is 5 over 5x minus 4. So the answer is 5 over 3 times the quantity 5x minus 4. All right. This one is going to be easier if you expand first. So this is really the natural log of 3x minus 1 minus the natural log of 2x plus 3. So you take the derivative of each of these. So it's derivative inside over the inside. So it's 3 over 3x minus 1 minus 2 over 2x plus 3. And that is your answer. So all you have to do. Right, so this one we have, it's the opposite of here. We have trig with the natural log of the inside. So the derivative of sine is cosine. We keep the inside the same, natural log of 3x. But then to take the derivative, right, you multiply by 3 and then over x. So you can just rewrite this as cosine natural log of 3x. So it's 3 over 3x. Sorry, these 3's cancel. All that over x. All right. And then these two, when I first assigned it, you guys couldn't do that because it was implicit differentiation. All right. So you didn't really have to worry about it. So what you would have to do for those is do this implicitly. And this is where you have to solve for dy over dx and go through. But to be honest with you, it's not going to be on the test. I wanted to show you on the notes just so you can, if you ever see something with a natural log and implicit, wherever you do the derivative of y's, it's dy dx, and you solve it and you factor out and do all that stuff. But we've been quizzed on that before, so that's not going to be on your next quiz, which won't be until not this week. It would be, I put it on this, I think it's another week from now or so. All right. All right. So the second was number 7 here. You had to do logarithmic differentiation, right? And this is where you take the log of both sides. All right. So if I take the natural, I have to take the natural log of y equals the natural log of all this stuff. Okay. Now I'm going to expand that. All right. So that's the natural log of x plus 1/2 natural log of x squared minus 1. Right? Remember, this side here turns into 1 over y dy over dx equals, then you take the derivative of each of these. The natural log of x is just 1 over x, all right, plus 1/2 times the derivative of x squared minus 1 is 2x over x squared minus 1, all right, and these 2's would cancel, and then you multiply both sides by y, all right? So all right, you're going to multiply both sides by y. So just to clean this up a little bit, remember, this is what y is, and this is going to go right there. So dy over dx, the answer is 1 over x plus, what is that, x over x squared minus 1. Now, if you just put y and draw the arrow, I told you can do it, absolutely. If you substitute it in, it would be x times square root of x squared minus 1. But you can just draw the arrow and put y there, just like I showed you guys on the notes. All right. All right, for part B, all right, this is take the natural log of both sides. So I get the natural log of y equals 1/2 natural log of x squared minus 1 minus, minus 1/2 natural log of x squared plus 1. All right. This is always going to end up being dy, or it's 1 over y dy over dx. But what's always going to happen is you're just going to take the derivative of the right side, and you're going to multiply by whatever y is. That's always going to be what your answer is for these types of problems. So 1/2 times 2x over x squared minus 1 minus 1/2 times 2x over x squared plus 1. These 2's would cancel there. The 2's would cancel there. So it's going to be all of this times y. And there's going to end up being your answer. I don't still feel like rewriting it all, but it's x over x squared minus 1 minus x over x squared plus 1 all times that. And that's your answer for that one. All right. Hopefully you guys are getting the hang of this logarithmic differentiation. All right. For C, same thing. Take the natural log of both sides. Then we just have to do a lot of expanding for this one. Natural log of y equals 2 natural log of x plus, because it's on top, 1/2 because it's a square root, natural log of 3x minus 2. Minus, because it's on the bottom, 2 natural log of x minus 1. All right. So now when I take the derivative, once again, this is going to be dy over dx. It's 1 over y, but I'm going to save time by just not having to write this out again. So this is 2 times 1 over x, which is 2 over x, plus 1/2 times 3 over 3x minus 2, minus 2 times derivative x minus 1 is just going to be, what is that? That's just 1 over x minus 1. And you could clean this up. This would be 3 over 2 times that quantity minus 2 over that quantity. And it's going to be all of that times y. And what is y? That's your y. All right. Now, obviously, on your test, when you have a pencil, it's easier to write down stuff. I would rewrite this. But it is not easy writing with this mouse. I'm not going to lie. All right. Last two. Same thing as all the other one, where you just keep condensing here. So it looks like for D, this one's hard to tell on this, but it's all of this to the 5th power. So whatever x, the 5 is going to be out in front of every natural log here. So any other exponent is going to get multiplied by 5. So this x is going to bring the 3. There's already 5 out there. So 3 times 5 is 15. So it's going to be 15 natural log of x. This 5 is really 1/5. 1/5 times 5 is just 1. So they're going to cancel each other out and just be the natural log of 5x minus 3. Minus 4, and then a 5 up there, that's what, 20? So it becomes 20 natural log of 2x minus 3. So now I take the derivative of all of those. So I get 15 over x, because the derivative of natural log of x is 1 over x, plus the derivative of 5x minus 3 is 5 over that, minus 20 times 2 over 2x minus 3, which would just be 40. And all of this is going to get multiplied by y. What is y? Y is this. Set it there. There's our answer. All right. Last one. All right. This is a long one here. Natural log of y equals 4 natural log of x plus 1/7 natural log of 3x squared minus 4 minus 4 natural log of 2x plus 3 minus 4 natural log of x plus 3. So your first step is always to expand this. It makes it so much easier. Now you're just taking the derivative of each thing. 4 natural log of x is 4 over x plus 1/7 times, remember, derivative the inside over the inside. So that's what, 6x over 3x squared minus 4 minus 4 times the derivative of 2x plus 3 is 2 over 2x plus 3 minus 4 times the derivative of x plus 3 is just 1 over x plus 3. Now, if we were to rewrite this, it would be 6x over 7 times this, minus 8 over 2x plus 3, minus 4 over x plus 3. Actually, for this last one, I'll just write it all out. So it's going to be 4 over x plus 6x. We're just multiplying by them. You don't even have to multiply it out, though. 7 times 3x squared minus 4 minus 8, because 4 times 2 is 8, 8 over 2x plus 3 minus 4 over x plus 3. All of that times y, and y is that. You don't have to rewrite y. You literally can just do this. Write y and draw a circle over it with an arrow. All right. If you have any questions on any of these, please let me know. You did not have to do 8 or 9. 8 on this. All right. We'll be doing our next lesson will be on doing the integrals of logs, du over u stuff. And then we'll do a couple days with that. And then we're going to do a quiz. We'll do a couple days review. So we won't be quizzing for a while, but we will be doing a good amount of review and more practice with this. If you guys have any questions, concerns, anything at all you need to talk to me about, please do not hesitate to reach out. All right. Hope all is well. Talk to you soon.